Hey y'all, in this video lesson, we're going to explore angles of elevation and depression to help us solve triangles. So I've got a little picture here to kind of help describe the difference between angles of elevation and depression. So I've got a little person and my little person is looking at something taller than him, and basically his eye level is kind of the line of sight or the sight line. And the angle above the sight line is called an angle of elevation. And the angle below the sight line is called an angle of depression. And that's going to help you in the word problems below because you're really going to have to draw a picture to help yourself visualize what you've been given and what you need to find, basically. So we have, and these just kind of take some practice. So the more you do, the more you draw them, the more you get an idea as to what they're saying and what they're asking for. So hopefully these two examples give you a really good idea as to how to do that. And you're going to feel silly drawing pictures, but just go ahead and do it. I'm a terrible artist, as you'll see in these examples, but the art doesn't matter. It's just, we just need the picture. A 6 foot tall person. So I'm going to draw a person. He is 6 foot tall, 6 feet tall, whatever, is standing 15 feet away from a tree. So I'm going to draw a tree. And this person is 15 feet away. You measure the angle of elevation to be 28 degrees. So this is the sight line. And right here above the sight line is 28 degrees. How tall is the tree? Now, a couple things we need to note here is that with that angle in 15 feet is the measure across, because that's the same as the one below. We're looking for this side. I'll highlight it actually in orange so you can see that it's different. We're looking for this side, the orange side. So I can find that. I'll call it opposite. You can call it X, you can call it H, doesn't matter. Call it whatever you want to call it. And that's going to give us this height, but I'm actually looking for the height of the whole tree. So after I find this length or this height, then I'm going to take that and add it to the height of the person so that I can get the entire tree. So that's why it's really helpful to draw a picture, because you need to see what's actually going on. For this side, I'm given an angle, and from that angle, I'm given the opposite side and the adjacent side. So if I think about SOHCAHTOA, the memory device, I'm going to be using tangent. Tangent of 28 degrees is opposite over adjacent. And then multiply both sides by 15. And that's going to give me my opposite side. So that gives me this little piece right here, which means I'm going to take that little piece, and the height of the tree is that little piece plus 6 feet because of the person, the height added anyway. And then we can add those two amounts. Make sure you're in degree mode because we're talking about degrees. We have 15 tangent 28, close that parentheses, plus 6. We get about 14 feet for our answer. And that's all it wants. It just wants the height of the tree, so we don't need to like solve for anything else. That's it. Now for the next one, we have from the top of a hill, I'll draw a hill, the angle of depression to a barn. I'm going to draw a barn. I should have left myself a little more room, but it's okay. That'll work. Is 15 degrees. So we're going to kind of consider the top of this hill our sight line. So kind of like in the previous example with the person looking, we're going to pretend like the hill is a person looking. So we've got the sight line, and then we have the angle of elevation. Whoops, that worked out. And the angle of depression is 15 degrees. So this is 15. If the hill is 30 feet tall, how far away is the barn from the hill? So we're looking for this orange part right here. We've got a lot of lines going on. I'm going to erase some of the lines that don't really, actually, I'm not going to erase them. I'm just going to make them dotted so they're not as pronounced. So basically we have, kind of visualize here, we have this triangle. So I've highlighted this triangle, and there's two ways you can look at it. And I'm going to go with the way that I have it written out here. Originally I had a different way planned, but I think this one's going to be a little bit easier. So I will show you both ways just in case you see it the other way, but we'll start with the easier one first. So I've highlighted this triangle. I've labeled the sides. Basically we're looking for this distance here, which actually matches this distance here. So those are the same. And then this distance here, 30 feet high, is the same as this distance here, 30 feet high. So I can use this highlighted triangle to find that missing distance X, I'll call it. And from, not tangent, just gave you the answer. From 15, we are given opposite, and we're looking for adjacent. So tangent 15 equals 30 over adjacent. Multiply both sides by X. Divide both sides by tangent 15. And if you type that in, if you're in degree mode, you should get about 112 feet. And that's it. That's all you're looking for. But if instead your brain saw, this is why I pivoted, because this is originally what my brain saw, and then I saw the other one. So if you saw this triangle instead, the green one, then you can still use it. So there's going to be one more added step that makes it slightly more involved, but you're going to get the same answer. So in this case, we are given the height of the hill still. We're still looking for the distance to the barn, but we need an angle. And we can find this angle because this line of sight is forming a 90-degree angle with the hill. So the missing angle is 75 degrees because the whole thing would be 90. And then we can use 75 degrees instead, and we have tangent 75 equals opposite over adjacent. I run out of room here. Multiply both sides by 30. And that's going to give us our missing side. I should have labeled that like with a variable like X, but it's okay. You get the point. Make sure you're in degree mode. We have 30 tangent 75, and we still get 112. So if we were to round it, 112. In either case, you're still going to get 112. So we had two different triangles and we got the same thing. So there are multiple ways to solve these problems. As long as you get 112, then you're solving it correctly. Or in the previous example, if you saw it a different way and you still got 14 feet, then you're good to go. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.